So just in general, all right.
Yeah.
So let me hold off on that for a second because we're actually going to do some problems together in the book that are exactly that. Anything else from homework? Yes. 3.3 number 33. Just a bunch of threes. Oh yeah, this looks yummy. So even I don't care what the function looks like. My mantra is that math doesn't care what's in there. There's a process I follow, and the process will work. Period. I don't care if there's fractions in there, decimals, things I don't even know what they are. There's a process that'll work. So they give you this. The equation looks kind of gross. It's this one here, right?
Yeah.
And the instructions are find the intercepts and then graph it. Right? And the nice thing is once you get the intercepts, it's awesome. You just need 2 points. Bang, you get a line. Kick ass. How do I always find the X-Intercept?
Make Y 0.
Yeah, make Y 0. Cool. Now take a second. If you guys haven't done that yet, figure out what that is. Put a 0 in for Y and solve it.
So always we start like this. I mean, we pretend that x is just 0, and later on we pretend y.
If I want the intercepts for whatever reason, that's how I get them. Yeah, if I don't want the intercepts, I'm not going to do that necessarily. I'm going to do whatever. But if I need the intercepts, I'm going to make one letter 0 to get the other guy's intercept. Why does that? And I really, always go back to why the hell does it make sense? Never go, well, that's what Jeff said to do, so that's what I freaking did. Why does it make sense? If I want to know where I am on the x-axis, what's true about every point on the x-axis? What's this point? 3, 0. There we go. It's a point. What's this point?
0.
So what's true about every point on the x-axis?
Y equals 0.
Y is 0. So if you make Y 0, it will tell you where it is on the x-axis. What's the x part that actually works on the axis? And then vice versa for the y-axis. On the y-axis, x is 0. So I always look at this like, again, I know I'm a supreme dork and I don't really care. We got this line where like, line, tell me, what's your intercepts? And so we I don't know, I got these torture methods in my head I don't want to get to. But you make Y 0. Oh shit, you made my Y 0. I'll tell you. I'll spill you. I'll tell you. Right? I have this whole scene in my head. That's good for you, man. You do what you got to do. So if I do make Y 0, what happens? What's 0 divided by 3? I love when this stays like 3 or something. That's dead, right? And then what do I do here?
Multiply by 4. -4.
Yeah, multiply by -4. To kill the negative and to kill the 4. The 4 dies, the negative dies, multiply both sides by -4. You get x is -4. It's crazy. Which means what? What's the x-intercept?
-4 is 0.
-4 is 0. And then to find the y-intercept, you do everything we just did except you make x 0. Is that cool? All right, I like it. This way.
Number 75 on the
Oh, okay. So this is a visual. Let's see. Sorry, I'm laughing at myself.
There was mostly just part B.
Oh, I got you. So let me slap this up here. I'm gonna need this here later anyway. Okay. So this is 75 in section 3.3. The one about the distance from home? Yep, okay. Ooh, that's right. Gotta be careful. Ooh. That's our homework. Rah. Can somebody cut off the light on that side? Hopefully this is actually working. That would be awesome. All right, cool. So my book is magic. So only answer is 75, right? All right. So finding the intercept should be relatively easy, right? They're staring you in the face. So what's the Y-intercept?
0, 200.
Kick ass. Some of you have been converted. What's the X-intercept? In this case, the T-intercept, really.
4 times 0.
4, 0. I love it. Now, so that's part A. And that's pretty easy. Part B is interpret what they mean. So can you look at this graph and figure out what this person, I think we talked about this there, what this person is doing? What is this? This is, what is this?
Hours.
Hour. So what does it mean here?
It's 0 hours.
So have I gone anywhere? Has anything happened yet? This is 0 hour, right? I'm somewhere. Where am I at 0 hours?
200 miles away.
I'm 200 miles away. So this is like how long it takes me to get home here, right? This is distance from home. So once I hit the x-axis, how far from home am I? 0. That's where it becomes 0 there, right? So what can you tell me about this person? Did this person go fast and then slow?
There's no really constant speed. for 4
Constant
hours.
speed. In fact, what's the units on speed? Miles per hour, right? And if you figured out the slope, I know this is going beyond what this has to do, but the slope would be change in y, which would be in miles, over change in x, which would be in hours, right? Time. And so anytime you figure out a slope, you're figuring out a rate of change. You're figuring out something per something. In this case, miles per hour. All right, maybe. So that's all extra stuff. So what the hell does this 200 mean? What does that 0, 200 mean? You guys already told me at 0 hours he was 200 miles away from home. Do the same thing for this one. Yourself. Don't say it out loud. All right, shouldn't be that. Is that cool? Who asked me? Whoever asked me, is that all right? Okay. All right. So anything else from homework? Yes, ma'am.
39. On 3.3.
Oh, all right. So this is you guys missed all that. This is a really good example of what I was saying earlier. Math doesn't care what's in there. You guys all right? Math doesn't care what's in the problem. But you do. This is the one that ax plus by equals c, right? So it says find the intercepts for this. And I desperately want you guys to get to the point where you're like, okay, that is not as nice as it could be, but it's barely worse. I mean, I know how to do this. How do you find the x-intercept? How do you find the x-intercept? Make y 0, right? Yes, Dr. Thomas. Or you guys just don't want to tell me. I don't know. Don't tell him. I don't think he knows. Right? That's all you got to do. Make y 0 to get the x-intercept. I don't care what the hell is it. I don't care. Math doesn't give a shit either. So in this case, A, B, and C, we're assuming they're all like numbers I don't know yet. X and Y are like our normal variables, our X, Y variables. So to find the x-intercept, you make y 0. So you get ax plus b times 0 equals c. And again, I love it when something survives this. What's b times 0? 0. So you get ax equals c. And divide by a. Yeah, so that's good. That's all I'll do. So you got one more intercept to do, and you do it the same exact way. Okay. All right. Yes, sir.
What's your problem 60 on section 3.3?
Oh, okay, good. All right. So remind me, for a vertical line. So if I had a vertical line, see right there. That by itself should be enough for you to tell me. I'm working my way towards the problem, by the way. I know the problem doesn't do this, but just to remind you guys. So for a vertical line, what is the equation of that line? X.
All the way to.
I heard somebody say it.
Yeah, 2.
Yeah, what's true about every point in that line? What never changes?
X.
X is 1. That's all the line. That's why it makes sense that that is the definition of this line. Why does Y not show up? Because we don't care. Y can do whatever the hell it wants to. All we want to make sure about this line is that X stays 1. That's if this line goes, no, I want to go that way. No, screw you. X has got to be 1. The minute you go this way, X is not 1 anymore. Does that make sense by itself? So a vertical line is an X equals something. A horizontal line, the same idea, except Y equals something. It can't go up or down. So, and tell me, what point is this? Well, let's do this point instead, sorry. Make it a little different. 1, 2. So this problem says, if you know that a vertical line goes through the point 1, 2, what will its equation be? Vertical line, what's got to stay the same? X. What is X in that point?
1.
So X has to always be 1. Now what if it's a horizontal line?
2.
Kick ass. Through 1, 2, it's got to be Y is 2. I only got to tell you 1 point for that line because it doesn't really depend on 2 variables, does it? Do you see? I only have to tell you 1 point to know that both of those lines, because it just depends on what X or Y is, and you know, X for this and Y for that. Kick ass. It is a weird problem when you first look at it. Like, wait a minute, Jeff said 2 freaking points on it. Well, special cases are always special. That's what I call them that. It's a little weird when you first see that, but it's not anywhere near as bad as you might think. Kick ass. Maybe. So that was section 3.3, starting at number 59. They're all like that. Now, once you see that, it's like bam, bam, bam. You can do all those quick. Okay. Anything else from homework? Are you guys going to the Mass? Anybody going to the Mass Study Center? How's it going? Anybody going there? You do? Okay. It's going all right?
Yeah.
So don't forget to fill out evaluations if you have a really good or really bad or something. Remember, there's 2 separate. There's actually 3. There's the one with all the computers in it. That one that's right next to the Mass Study Center. That's for 80, 88, 90 specifically. And then you got the main Mass Study Center, the one that have computers around the outside. That's for every math there is, right? And then upstairs there's the one-on-one intensive help for any class. All right, just don't forget about those. Free, relatively little chance of dying. Comparing it to Craigslist, you know. Okay. All right. So no other questions from homework? We're going to get back into Amanda's question because that leads us right back into what we were talking about last time. So before we get there, let me make sure you guys remember how to do this. How do you find the slope of the line between or going through -4, 7 and -7? Oh, it doesn't matter, Jeff. It doesn't have to be nice. Yes, sir.
You do y2 minus y1 over x.
Kick ass. So you know m. You know, if you want a letter for slope, you obviously use m. Like I said, I think it's French. Over x2 minus x1, kick ass. And why does it make sense? Because in English, slope is rise over run. And when I rise or fall, it's my y's that change. If I run, it's my x's that change. And that totally makes sense. Let that make sense. So if I give you points, you can just plug it into this equation and get the slope. You don't have to plot the points. So do that real quick. Be real careful about negatives. Negatives live to screw us up. Negatives are evil. Negative bank account, bad. And then they charge you more money. I'm like, I don't have any money. Why are you charging me money for not having money? That's kind of you. Thankfully, that hasn't happened recently. I don't want you guys worried about it. All right, so let's see. So here's what you should do. There's a y minus another y over an x minus another x. You fill in what the numbers are so you don't feel like there's already a negative there. Why do I need another one? Of course you do. There's a minus in the equation. So I don't know which way you guys went. If I just go the way I've written it up on the board, it doesn't really matter. y2 minus y1 over x2 minus x1. So then you get negative 2 over, negative 7 plus 4. So negative 2 over negative 3, which is 2/3. So even if you did it the other way, you should have still ended up at 2/3. Kick ass. I want to make sure everybody's up to speed with that. Yes, sir.
How do you get 2/3 positive?
Are you cool with negative 2 over negative 3?
Yeah.
And so what do the negatives do?
Like, cancel each other out.
Kick ass. Right? Negative divided by negative is going to come out positive. Now, real quick thing about that. What does this mean on a graph? What would it tell me about on a graph? What would this tell me to do? Yeah, start at any point on the graph on the line and go up to over 3. What would this tell me to do? Down to back 3. Kick ass. But of course, if I go up to over 3, down to back 3, it's still the same line, right? It doesn't matter. That's why it's kind of nice. Math says, "What the hell are you doing? What the hell? This is the same freaking number. Stop doing that shit." And we go, "Math, it's all right, man. Visually, this means something else." It's still the same line. That's why math is right. It's still the same stupid line, but it's just a different way to get around. I want to be able to get back to my house, right? So if I go somewhere, please let me get back. Thank you. All right. So let's jump into the next level of that, which is using slope to help you do stuff. So let's do this first one together, and then I'm going to have you guys do the other two. This is page 43. Here, I guess you guys can see this. So first thing, help me out. What is the... Well, real quick, let's remember, what's the general form of a line that we know? Gas. And the weird thing, it's really weird. If you think about it at all, it's really weird. If you get y by itself in a line, the slope and the y-intercept just fall into place. It's almost too nice to believe. And it works for other things. Eventually, we're going to talk about circles. If you set up the equation of a circle correctly, you'll see the center and the radius. That's the two things you need for a circle. If you do other things, ellipses and so forth, you'll see all this information from just looking at the freaking equation if you put it in the right form. So this is our first little foray into that world. So tell me, from this guy, what's the slope? 2 over 1. Kick ass, because it's in the right place. And what's the y-intercept? 0, negative 5. Kick ass. I love it. So B is just the y piece of the y-intercept. How do I plot the y-intercept? Yeah, don't go anywhere left. Get out of there, Jeff. You don't go anywhere left and right. 0, right? You just go down 5. So there's the y-intercept. And I always plot a point on the line first, because the slope tells me if you're on the line, I'll get you back there. If you're not on the line, I can't help you out with shit. So I plot that point, and now from this point I go, what does this tell me to do?
2 up.
Yeah, up 2 over 1, so up 2, 1, 2, over 1, bam. Up 2, over 1, bam. That's enough. Shoot. Hopefully your line is,
Question.
straight. Yes?
Where did you get 2 over 1? How did you
Oh,
get that?
what's the slope? Slope is 2. And any whole number I can just put over 1. Right? I didn't just create that. It's always there. We just normally don't write it. right? Because we're lazy or we're frugal with our time. I mean, how's that? Is that cool? I mean, does that make sense? I don't mean to point you out, but you asked me the question. All right, so you guys do the next two. If you already did the next two, awesome. Pick your favorite wall and stare at it for a minute. Does everybody pick their favorite wall? We have 4 ceilings there too. Alright. Catch up with you guys. Here, what's the slope? Negative 1/2? Got it. Excellent. What's the y-intercept? 0, 3. Kick ass. So where do you start? Cool. You always got to start at a point on the line. It doesn't even have to be the y-intercept, to be honest. Whatever point you know, you can start there. So I just happen to know the y-intercept is 0, 3. And what's the slope tell me to do? Down 1. Over 2. Kick ass. So I can go down 1, over 2. Now let me just say something kind of weird. I'm looking at the slope like it's negative 1 over 2, which is what it is. Can I write that a different way? How else could I write that? Yeah, I could put the negative on the bottom, right? And of course, again, math would go, don't you have better shit to do? We're like, math? That's what some of us think of you. Oh. But what does this tell me now that I know this is slope? What does this tell me now? To go up 1, kick ass. Up 1, back 2. So if I try it from starting from here, if I go up 1, back 2, I'm still in the same freaking line. Okay, good. I'm trying to make that point. This is kind of weird, but it's very useful sometimes. Yes?
I guess I get a little confused as to why it's on the positive side, not on the negative side, when you do down 1 over 2.
So starting at this point. So if I look at it as if it's negative 1 over 2, right? And the top is rise, so actually it's negative, so I'm going to fall 1. Now you ask me why I don't go this way?
Right.
Okay, because the 2 is not negative. Do you see what I mean? It's negative 1, so I definitely go down 1 because it's the negative direction. Now here, what's the negative? What's the positive direction? Because it's positive 2. That's the positive direction.
I guess I was getting confused. If the negative doesn't affect both of them.
Can't. If the negative was on both, it would cancel. It would have been positive to start with.
Okay.
Yeah. There's only one negative, and that's why the number is negative. So I can either put it on the top or the bottom.
It's part of what I'm confused. So.
And then if you do make mistakes like that, just step back and say, well, what's the slope of my line supposed to be? Is my line supposed to be going like this or like that? Up or down? What's my line supposed to do? Go up or down? Yeah. What's the slope? Is it positive or negative? The slope here is negative.
So down.
So it's supposed to go down as I read across. So you can just step back and check at the end after you've plotted some points. And then you'll go, if you're going this way, you're like, oh shit, I went the wrong way somewhere. You'll catch a mistake, no big deal. Right? Maybe. So anytime I see negative slope, I I've got to be going down as I read. Right, and here, we read this way. So then, let's see if I can freehand. All right, good. All right. Make whatever sound effects you want. What's wrong with this guy? Yeah, you gotta, well, you can find the y-intercept and the slope at the same time if you solve for y. Kick ass. So how do I solve this thing for y? Add 2x. And see how I shoved the 2x in front of the 9 just to put it in the right kind of setup, right? And then divide by -3. So you get y equals -2/3 x minus 3. Let me stop there for a second. Is that what you guys got? You never know. I've made mistakes. All right, so what's the slope? -2/3, and the y-intercept? Yeah, 0, -3. Kick ass, so 0, -3, and then from there I want to go down 2 over 3, or I could go up 2 back 3. That's my 7 people. Hey. And then you just connect the dots. And it's doing what it's supposed to do. It's a negative slope. It's supposed to be a negative slope. Now, real quick, here's the ultimate way to check this. What point is this? Yeah, -3, -1. So what's that point supposed to do with this? What's it supposed to do here? It's supposed to work. So if I plug in -2 times x, which in this case is -3 at that point, minus 3 times -1, that's supposed to be 9. So I get -6 plus 3 is 9, check. Kick ass. So you can always, if you're graphing your own line from an equation, you can always check by picking a point you found and plugging it in, making sure it works. What always sucks is if you do this wrong and you think your line's wrong when it's really right. But still, just don't do this wrong. Maybe. All right. Kick ass. So here's the next level of that, if you guys don't have any questions on that. And actually, before I do this, here's the most common mistake. If I give an equation like this, you guys should be able to pick up on this, and somebody tells me the slope is 4 and the y-intercept is 0, -2, is everything okay? What have they done wrong? Yeah, they just look at the first number. That's not the point of the form. The form says whatever number is in front of x is the slope. So if you got it written the wrong order, you don't suddenly change the slope. There's a line, then you move it, and then the line goes, holy shit, I'm moving around. You can't change the line. Maybe. Just make sure it's in the right order, or just make sure that you're picking the right numbers off. It should be slope there and y-intercept there. Okay, maybe. All right. Okay. So if everybody's cool with that, let's look at the next level. We're going to do a few of these kind of things. We'll start here. Let's see what you guys can do. Just take a minute and try to do what it says to do. Just so you make sure you understand. Again, math people were very creative. So we said, what are we going to call this equation that has a slope and the intercept in it? I know. Let's call it the slope-intercept. So when they say slope-intercept form, they mean mx plus b. So watch this. If I ever ask you to find the equation of a line, what two things do you need? What two things do I need?
Slope and Y-intercept.
Slope and Y-intercept, kick ass. And we're about to find out what if I don't have the Y-intercept. We're going to make another equation that I could use. But for right now, if I can find those two things, I can set up my equation and be done. So the Y-intercept is staring me in the face. So what's the value of B going to be? You can finally say what you want to say. Yes, sir. 2. Kick ass. The Y-intercept is 0, 2, so the value of B is 2. Now how do I find the slope? So if I start here, here's a point that's definitely on the line, and any other point that's definitely on the line like that one. I fall, how many? 2, and then I run 1. So the slope is -2 over 1. Yes, sir.
On test, are you going to count points against us if you just put net slope as -2?
No. I'm just making a point about where the 1 goes, right? So slopes care about the tops and the bottoms. Math is like, that's freaking -2, dude. What do you write? So when I write the equation line, I'm not going to write that. I'm going to write y equals, what's that? -2 x plus b. 2. I'm just plugging the stuff in that I found. Right? I can find the slope, I can find the intercept, and then I plug those values in, and I'm done. Okay, maybe. So you guys do this. All right, so this one's not too bad. What's the Y-intercept? 0, 3. So then B is going to be 3. And then how'd you find the slope? Well, let's see now. If you go between these two, you would fall 3, but then you would run back 3. So the slope would be -3 over -3. So don't forget both directions, both dimensions. Or, you know, even better is there's a point right there. So back 1, down 1. So then the slope would be -1 over -1 should be coming out to be 1. And why does it make sense that it's positive? Because our line is going up. Right? That makes sense. I know the slope is going to be positive because the line is heading up. Read you guys at all. I think half of you know this stuff really well, and the other half are like, I don't even know where to start asking questions. So you're being quiet for different reasons. Alright, so now slapping my formula together, I just throw in there what M is. 1.
Plus 3.
Yes. And again, you can check it if you wanted to. This point is -3, 0. If you plug a -3 in for X, you do get 0 out for Y, so it checks. Okay, yes, you can always do that. Okay. All right. So here comes the weirdness. Before we talk about this, I'm going to talk about this other thing. Yeah, I like it. So 2 things I'm going to talk about right now. I'm going to talk about parallel and perpendicular, because I don't think we've talked about that yet. And then the other equation of a line. All right. So, parallel normally people get pretty quickly. What's got to be true about 2 parallel lines? And what must be true about the slopes of 2 parallel lines? Yeah, it should kind of make sense. They have to be exactly the same. All right, so here I'm going to call this line 1 and line 2. So if I write that, that is the, what does that represent? Slope of line 1, kick ass, right? And that must equal exactly the slope of line 2. Because if they were at all different, if that was 1 and that was 0.99999, then they won't be rising at exactly, they're going to hit somewhere back there or up there, they're going to hit each other. They have to stay the same distance apart. They have to be exactly the same slope. Yes. So that makes total sense normally. Perpendicular is where things get weird. So real quick, just to show you, here's the symbol for parallel. Because again, math people are very creative.
What's the symbol? How about two parallel lines?
What the hell does perpendicular mean? Beautiful. So there's a lot of different ways for two lines to hit each other. Perpendicular is a very precise, specific case of that. They have to meet at 90-degree angles. So perpendicular means two lines meet at 90-degree angles. So let me see if I can create a situation here real quick. Let's see what you can do, Jeff. I don't know, dude. Let's do this. This exciting. What's the slope of that line there? Call this line 1.
3, 1, or 3.
3 over 1, so 3. Is that cool? Because I went up 3 over 1, kick ass. So the slope of that line is 3. Now if I want to draw in there a perpendicular line, it's not going to be perfect. Let me see if I can make you believe me a little bit as to why this works the way it does. If I think the perpendicular line has a slope of -3, I'm so desperately wrong. And that's not a bad guess to begin with. But if it had a slope of -3, there's no way in hell that that's a 90-degree angle there. Let me just draw it. That is not, and do you see that? There's no way there's a 90-degree angle. And I know I don't draw very well, but I draw well enough to say, yeah, that's a bad drawing, Jeff, but that ain't no 90-degree angle. Right? Don't analyze my grammar. All right. So not only, I mean, it should make sense. The slopes have to at least be opposite signs, right? If one's positive, the other's got to be negative to come back and hit it. Does that make sense? All right, maybe. To have any chance to hit it at a 90-degree angle. But it not only does it have to be negative, it also has to be the reciprocal. So slope 2 has to be -1 over 3. Let's see what happens. So if I have a -1/3 slope, starting here, I would go down. I like it. That was funky. Doesn't take much. I'm easily used. So from here, where do I go? I like that musical. Yeah, down 1 over 3. And now if I draw that, that looks more like, now this is not a proof, but that certainly looks closer to a 90-degree angle, right? So that's the actuality, is if I have two lines that are perpendicular, their slopes have to be negative reciprocals. Another way that it's called, and for some reason students like this better, which is fine. Doesn't really help me out, we're shit, but if two numbers are negative reciprocals, what is M1 times M2 here? What's the product of those two slopes? Yeah, 3 times -1/3, -1. So that's always going to happen. So two perpendicular lines, they have to be negative reciprocals of each other, which means that if you multiply their slopes, it'll come out to be -1 always. So let me say this a different way. So parallel lines have to have exactly the same slope. Perpendicular lines have to have totally opposite. Because how many opposites do we know? One opposite is to change the sign, then that's the opposite. What's another opposite? To flip it. So you do both to make it totally opposite, right? So parallel, exactly the same. Perpendicular, totally opposite. So tell me this. What's the slope of the... Oh, and here's the symbol for perpendicular. I like this one. It's a little more creative, at least. That's the symbol for perpendicular, right? 90-degree angle. So what's the slope of the perpendicular line to this line? Yeah, because what's that guy's slope? What's that guy's slope? 2/5. So it's the perpendicular slope. It's got to be the negative reciprocal, negative 5/2. So perpendicular slope would be negative 5/2. Kick ass. Maybe. Okay. All right. So here's the next piece. This is the more interesting piece. This is kind of weird. So let me give you a visual. Let's say there and there. Sure. All right. A beautifully straight line. Somebody help me out. What's the slope of that line?
1/3.
Yeah, I had to go up 1 over 1, 2, 3. Kick ass. So slope is 1/3. Now, I happen to highlight those 2 points, right? So that I use them. You use them to figure out the slope because it's the easiest points to tell what they were. On a straight line, does it matter which points you use? Because the slope can never... If it did change, suddenly you have a kink, right? In your hose, you got to go, shit. So you can spread it. Okay. I don't want a kink in my straight line. So what the hell are you talking about, Jeff? I don't know. So remind me, the slope equation is y2 minus y1 over... And why? What are those little subscripts for? Why are those little 1s and 2s? 2 points. Exactly. I've got 2 points. But what did I just say? Do I have to use a specific 2 points? No. I could use 1 point. Let's call this one x1, y1. I definitely have to have a point, and then does it matter what the other point is? So it could be any point. And what is any point on this line? This is the weird part. Maybe it's a little weird. It's x, y. There. That's any point on the line, right? Any point on the line is x, y. The x and the y that goes with it. That's any point in the line. Stay with me. As you lost me the minute you came in the room, John. All right. So instead of saying I have to use a specific second point, I could use any frickin' point as a second point. So I can just put y and x. I just love it. I can almost hear your thoughts. Some of you are like, ooh. And look, I go, oh, wow, Jeff, that's amazing what you have just done. This is incredible. Right? I'm like, wow, your thoughts are so sarcastic. But the thing we've just done, this equation says you have to have a first point and a second point given. But what in reality, I can have a point and then any other freaking point I want. It's going to come out to be the same stupid m because it's the same straight freaking line. So what's the amazing part about this? Some of you guys know where I'm going with this. If I multiply both sides by x minus x1, let me rearrange this. So I get y minus y1 equals m times x minus x1. All right, let me put this up on the top of the board. All right. So now we have 2 forms of the equation of a line. And again, I can hear your thoughts. That's 2 more than I wanted. Oh, that's stupid. So one equation we have is this guy. And remarkably enough, we call it the slope-intercept form. Just take the y off. It's the y-intercept over there. This one, so I can only really directly use this if I can find the slope and if I can find the y-intercept. Can I always get the y-intercept? No. So that's where that guy comes in. Look what this guy got. What's this guy got? Show me what you got. See a big head, this guy. So this guy's definitely still got the slope. But what's this? That's a point. That's the point on the line. So if I know, and does it have to be the y-intercept? No. Be any freaking point. So we call this point slope form. Again, continuing our creative streak. We're on a roll, guys. All right, so let me show you how this kind of thing is used. All right. So here's and this is kind of like what I was saying earlier. Anytime I ask you to find the equation of a line, you need two things: the slope and a point. If that point is the y-intercept, kick ass, because I can use a smaller equation. Yay. If it's not, oh shit. So here we go. Here's an example. Find the equation of the line perpendicular to y equals 1/3 x minus 1 going through -1, 4. All right, so this is what you do. This is what you do with all of math. You break it into parts. The people that can break things into parts are the ones that do math really well. If you try to do everything at once, you're going to go slowly insane. Some of you guys are like halfway there. So remember, what do I need for the... Do I have the y-intercept? Where is the y-intercept? Tell me what it is. What's got to be true about the y-intercept? How do you find the y-intercept? You make x0. So a point could only possibly be the y-intercept if its x part was 0. Do you see how those go together? How do you find the y-intercept? You make x0. So what's true about every y-intercept? X is 0. Because that's how you get there, right? Is x 0 in that point? Is x 0 in this point?
Oh, no.
Okay. I'm getting a little concerned. I'm like, am I off meds? Am I supposed to be? I don't know. So this is not, do you guys get this? This is not the y-intercept. This is so desperately not. I don't make x -1 to find the y-intercept. When did I start doing that? So if it was 0, 4, b would be 4, kick ass. Yeah. But too bad for us, it's a little bit worse. But I break this into parts, so 2 parts. I gotta find the slope. There's an O in there, Jen. There you go. And I gotta find a point. All right, I'm gonna do this one. I'll do my half. I found the point. There it is. Now the first part's not that bad either, right? How do I figure out the slope of my line? Nope. Because my line is how related to that line? Yeah, my line is perpendicular to this one.
It's -3.
-3. So whatever that guy's slope is, my slope is the negative reciprocal. I'm starting, you guys see the steps I'm taking here? I'm like, I gotta find a point. They gave me a point. Check. I gotta find a slope. What the hell? They gave me a freaking other line. I'm perpendicular. Okay, cool. I know perpendicular, how it relates to slopes. You see, that's the steps you take. So this guy's slope is 1/3, so our slope, -3. Check. I stopped there for a second. Just using all the information the problem gave me. Why would there be absolutely 0 reason to plug this into that? Yeah, -1, 4 is on my line, and my line is perpendicular to this line. These have nothing to do with each other. These are 2 pieces of information. Why did they give me 2 pieces of information? Because I need 2 pieces of information. They're separate from each other. You guys see that? The only thing I use this guy for is to get his slope, and then I throw him away. Right? Not a good life philosophy, but it works for math. I'm done with you. Get away. All right, so now I call this the SDT level. So no matter what I tell you, once you get the slope and a point, you do the same damn thing. You plug in what you figured out. Right? So now, which equation can I use? I know some of you guys might know some of that, but I have to use this one, right? I don't have the Y-intercept. So help me out. What goes into this equation? What goes here? Yeah, good. The y piece of the point that I've got. I love it. So y minus 4 equals what goes here? Negative 3 is crazy. Right? That's why we figured it out. Negative 3 times x minus, kick ass, the x piece of the point that I know. And now what do you think I want you to do with that? Get y myself. Just make it look better. Right? Put it into the simpler form. Right? So y minus 4 equals negative 3x plus, plus minus 3. And then you add 4. Negative 3x plus 1. Just cleaning it up a little bit, right? That's the simple step, should be. Just clean it up a little bit. All right, so this is actually section, I think it's 3, believe it or not, it is 3.6. Shit. So, let me say this. I think on Thursday, you know what's going to come out of my mouth right now. We're going to have another quiz. It's going to be from like 3.3 through 3.5. So it won't have the stuff we just did today. It'll be 3.3 through 3.5. Cool. Thursday, not tomorrow.